Okay, I'm going to do an example of how to use the product rule. And the product rule is used when you are finding the derivative of a product of two functions of x. So you might notice that right here we have two different functions of x. We have the first bracket, which is one function of x, and then we have the second bracket, which is another function of x. Now, one way to do this is to simply multiply out these two binomials and then take the derivative of that resulting polynomial. But it will be useful later on to use the product rule for other types of functions, and so it's a really good idea that you practice the product rule right now and get used to it. So let's have a look at the product rule. So the product rule states that the derivative of a product of two functions of x, u and v, so the derivative of u times v with respect to x, dx, is equal to u, the function, multiplied by the derivative of v with respect to x, dv dx, plus v multiplied by du dx. So we name the first function u, 6x squared minus 5x, and we name the second function v, 2x plus 1. And so you'll notice that we have one function u, the first factor in this product, the other one is v, and the other things we're going to have to figure out are the derivative of the function u with respect to x and the derivative of the function v with respect to x. So over on the side, actually we'll write it down here. So right away it's a good idea to state what u and v are. So what are u and v? These are the things you're going to ask yourself when you get started. So u will be the first function, 6x squared minus 5x. And v will be the second function, 2x plus 1. Now notice, we also need the derivative of the function u, like right here, du dx, the derivative of the function u with respect to x. So du dx will be the derivative of this function with respect to x. Well, that's just like what we've been doing all along using the exponent rule. So let's just do that. So that will be 12x minus 5. And the other part of this one is dv dx, which is the derivative of the function v with respect to x, which will be the derivative of 2x, which is 2, and the derivative of 1, which is 0, so it just ends up being 2. So now we have all four parts of this product rule. I'm going to point to this. So the u, there's one part, and the v, those are each of the factors in the product of two functions, and then the derivative of each, there and there. So those exist down here and here, and the original u and v, which I did not put a box around yet, are right here and here. Okay, let's now write the derivative of this function y. So that can be named in different ways. We can call it dy dx, knowing that y is equal to the product of two functions u and v, so that's actually duv dx. We also know that sometimes we call this y prime, so it has different names, but it's all to create the same thing. So this will be, the first part is u, so we need the function u, 6x squared minus 5x. And that is multiplied by dv dx. dv dx, which we did down here, is 2. And then we add to that the v, which is 2x plus 1, multiplied by du dx, which is 12x minus 5. So now, it's really just a matter of multiply and collect like terms. We already have the derivative, it's just not in a form that we would actually leave it. So we just need to multiply out. So we need to multiply 2 by each term inside these brackets, 12x squared minus 10x. And now we have a binomial multiplied by another binomial. So perhaps you recall FOIL, right? So 2x times 12x, which is 24x squared, and 2x times minus 5, which is minus 10x, and 1 times 12x, which is 12x, and 1 times minus 5, which is minus 5. Collect like terms. All right. The like terms are, we have in the first set of like terms would be the 12x squared and the 24x squared. So that is 36x squared. Then we have terms with just x to the power of 1. So there are minus 10x plus 12x. So that's minus 10, which is minus 20, plus 12, which will be minus 8x, and minus 5. And there we have our derivative. So there's an example of the product rule. There are other notations, but they essentially do the same thing. Thanks for watching.